Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider. You are watching Learn and Teach by Sir Ayaz. So I was doing O-level past papers and this time I have selected CIE Chemistry 5070 paper 4. For this video I have selected the paper 41, variant 41, and it's of May-June 2023. It is paper 4, which is alternative to practical. So you must answer on the question paper. No additional materials are needed. Instructions for this paper is answer all questions. Use a black or dark blue pen. You may use an HB pencil for any diagrams or graphs. Write your name, center number, and candidate number in the boxes at the top of the page. Write your answer to each question in the space provided. Do not use an erasable pen or correction fluid. Do not write on any barcodes. You may use a calculator. So it means there are some calculations. So you need calculator for doing those calculations. You should show all your working and use appropriate units. Some information in this paper, that's total mark for this paper is 40. The number of marks for each question or part question is shown in brackets. Notes for use in qualitative analysis are provided in the question paper. We have this kind of note for the qualitative analysis. These are the tests for anions. So this is for anions. Then you have list for the test of aqueous cations, test for gases, last but not least, flame test for metal ions. So let's continue. Here's question number 1. A student uses chromatography to separate the dyes in a food coloring. Figure 1.1 shows the apparatus the student used. Here is apparatus X, which is beaker. You have solvent, you have start line, chromatography paper, you have spots for the dyes, and there's a lid to prevent the loss or evaporation of the solvent. Name apparatus X. It's a beaker, so you'll write beaker here. B. State why it is important to have a lid on X to prevent the evaporation of solvent from the beaker. C. State why the start line is above the level of the solvent drawn in pencil. So a straight line should be above the level of the solvent because so that the dye does not dissolve of paper into the solvent. And why we are using pencil in order to draw the level start line, because the pencil does not dissolve in the solvent. So that dye does not dissolve of paper into solvent. Pencil is insoluble. In the solvent. Moving to next part. D. The RF value of one of the dyes in the food coloring is 0.6. In the separation, this dye travels 5.7 centimeter. Calculate the distance traveled by the solvent during the separation. So you know that in order to calculate the RF, we need to divide the distance traveled by the dye with the distance traveled by the solvent. Distance traveled by the solute. Here in this case, it's a dye divided by distance traveled by the solvent. Putting the values, RF is 0.6 is equal to 5.7. And let's consider X as the distance traveled by the solvent. So X is equal to 5.7 divided by 0.6. 5.7 divided by 0.6. What you will get? You will get 9.5. 9.5 centimeter. Moving to next question. Question number 2. White vinegar is a colorless solution containing ethanoic acid. Student titrates 0.4 mole per dm cube aqueous sodium hydroxide with 2 samples of vinegar A and B. Student does 4 titrations, 2 with A and 2 with B. The student, step 1. In step 1, uses a volumetric pipette to add 25 centimeter cube of 0.4 mole per dm cube sodium hydroxide to a conical flask. Step 2, adds 5 drops of an indicator to the conical flask. Step 3, adds A from a burette while swirling the contents of the flask, adding drop by drop near the end point until the solution just changes color. Step 4, empties the conical flask and rinses it with distilled water. Step 5, repeats steps 1 to 4. Step 6, repeats steps 1 to 5 using B instead of A. A part 1. Figure 2.1 shows the burette readings for the 2 titrations with vinegar A. You have titration 1, titration 2. Record the burette readings in table 2.1. Complete table 2.1 with the volume used in each titration. So for titration 1, final burette reading, it's 24.1234 5 6 7 8 9. 24.9 should be 24.9. What about the initial reading? It's 0. So we write 0 here. Titration 2, final burette reading is 37.1234 37.4. So I will write 37.4. What about initial reading? 12.123 should be 12.3. Volume of A used per centimeter cube in titration 1 should be 24.9, because you have to subtract the initial volume from the final volume and you will get 24.9. What about titration 2? You have 37.4 minus 12.3. 37.4 minus 12.3. You'll get 25.1. Moving on to next part. Number 2, figure 2.2 shows the burette readings for one of the titrations with vinegar B. Here's titration 4. We have initial and final reading. Figure 2.2, record the burette readings for titration 4 in table 2.2. Calculate the volume of vinegar B added in titrations 3 and 4. Here's table 2.2. For titration 3, they have provided us the final and initial burette reading. Final reading is 12.6 and initial burette reading is 0.1. So if you subtract 0.1 from 12.6, what you will get? You will get 12.5. What about titration 4? Final Buret reading 25.123. So you have 25.3 here. So I will write 25.3. Initial reading 12.12345 12.6. So I will write 12.6. In order to get the volume of B used for titration 4, we need to subtract 12.6 from 25.3. So the answer will be 12.7. Calculate the mean volume of A and of B needed to neutralize 25 centimeter cube of 0.4 mole per dm cube aqueous sodium hydroxide. Mean volume of A. So we have 24.9 and 25.1. 24.9 plus 25.1. So in order to get the mean, we will divide it by 2. 24.9 plus 25.1 divided by 2 will get 25. What about mean volume of B? We have 12.5 plus 12.7 and then we'll divide it by 2. 12.5 plus 12.7 divided by 2, we will get 12.6 as of mean volume of B. C. Suggest why the titrations using A and B are repeated. So we need to check that results are consistent, so that the results are consistent. We need consistent result. D. The equation for the reaction between ethanoic acid and sodium hydroxide is shown. This is a reaction CH3COOH plus NaOH gives CH3COONA plus H2O. The answer to B shows the mean volume of B used to neutralize 25 centimeter cube of 0.4 mole per dm cube aqueous sodium hydroxide. Calculate the concentrations of ethanoic acid in B. Give your answer to an appropriate number of significant figures. Now we have mean volume of B. What is the mean volume of B? It is 12.6. So I'm writing the mean volume. (12.6 centimeter cube). Other information which are provided in this question is the number of reacting moles. If we will consider the number of reacting mole of ethanoic acid as N1 for ethanoic acid, it's according to the equation 1 mole. What about the volume of ethanoic acid? It's provided 12.6, and we need to calculate the concentration, which is M1 is equal to sodium hydroxide. The reacting moles for sodium hydroxide is also 1. N2, I'm using N2 for sodium hydroxide, so I will write 1 mole for N2. What about the volume of sodium hydroxide? It's also provided. You can see it's 25 centimeter cube, so I will write 25 centimeter cube. M2, it is also provided, which is 0.4 mole per dm cube, so you'll write 0.4 mole per dm cube. Now we have the equation can use this equation in order to calculate the concentration of ethanoic acid. M1 V1 by N1 is equal to M2 V2 by N2. N1 and N2 will be cancelled out as both of these are of one one moles. So now we are left with M1 V1 is equal to M2 V2. We need to calculate M1. Rearranging the equation, we will get M1 is equal to M2 V2 by V1. Placing the values, M2 is 0.4, V2 is 25. What about V1? V1 is 12.6. 0.4 multiplied by 25 divided by 12.6. We will get 0.793. You can even write 0.794. So we will write 0.794 because in the question they are saying you have to write appropriate number of significant figures. So I will round it off to 0.794. E, use your answer to D to calculate the mass of ethanoic acid in 500 centimeter cube of B. MR of ethanoic acid is provided, which is 60. So first of all, I need to calculate the number of moles of ethanoic acid in 500 centimeter cube. So the concentration is 0.794 mole per dm cube, which means it is in 1000 centimeter cube. So I will write 1000 centimeter cube contains 0.794 moles. Therefore, 500 centimeter cube contains X moles. Do the cross, we will get X is equal to 0.794 multiplied by 500 divided by 1000. So what we will get? 0.794 multiplied by 500 and divided by 1000. We will get 0.397. So 0.397 will be multiplied by 60. So the mass will be 23.82. So you write 23.82. Because I have multiplied the moles by the MR in order to get the mass. Remember this formula. In order to get the mass, you need to multiply the moles by the MR. These are the moles we obtained, 397. Number F. Use your answers to B and E to calculate the mass of ethanoic acid in 500 centimeter cube of A. What about the mean volume of A? It is 25. So using the same formula, if you use the same formula, M1 V1 is equal to M2 V2. So M1 is for the concentration of ethanoic acid. I will write M1 is equal to M2 V2 by V1. M2, see it again, 0.4 M2 and volume is 25. 0.4 volume is 25. What about the volume of A? It is also 25. The volume of A is 25 centimeter cube, the mean volume. So these will be cancelled out. So the concentration is 0.4 mole per dm cube, which means 1000 centimeter cube contains 0.4 moles. Therefore, 500 centimeter cube contains X moles. So X is equal to, do the cross, 0.4 multiplied by 500 divided by 1000. 0.4 multiplied by 500 divided by 1000. 0.2 moles. In order to get the mass, multiply the moles by MR. So 0.2 multiplied by 60. 0.2 multiplied by 60, and we will get 12 gram. So this will be the final answer. G. Suggests why the conical flask is rinsed with distilled water and not 0.4 mole per dm cube aqueous sodium hydroxide between titrations. So distilled water is used to remove any chemicals present in it. We can't use NaOH because definitely some of the sodium hydroxide would remain in the flask and more ethanoic acid would be needed. So you can write any two from these statements. Any two from distilled water used to remove any chemicals from the flask. We can't use NaOH because then some NaOH would remain in the flask. Last, again, you can't use NaOH because more A or B ethanoic acid would be needed. H. Some vinegars are brown rather than colorless. Suggest why this titration method would not be suitable for finding the concentration of ethanoic acid in brown vinegar. The color change couldn't be clearly observed. That's all for this video. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.